All right, so today we are looking at day 9 sinusoidal applications, very similar to what we've been looking at before, but now we're given a problem. Okay, the questions are going to look a lot like this, or we'll have to graph them, put them in an equation, and figure out what they look like. What's coming up? Wednesday, May 24th, we are going to have our test, which you will have a sinusoidal application on as well. And on June 7th, our selfie assignment is due. Right, let's get into sinusoidal applications. So the first thing we're going to start off with is the formula. So the formula for sinusoidal functions is y is equal to, and then we start with a capital A for amplitude, sine, bracket, and then our k, which is where we find our period, because our period is equal to 360 divided by k. And then we have bracket x minus p, which is our phase shift, and then plus d, which is our displacement. P for phase shift, D for displacement. Perfect. All right, so let's check out this question. During high tide, we have the water depth in an ocean harbor is 20 meters, and during low tide, it's 8. So we have a height, our maximum, 20, and our minimum of 8. If the tide cycle is 12 hours, the period, and the high tide occurs at 3 a.m. All right, let's go ahead and try to sketch something out. So it looks like we have to go for one cycle is going to be to 12, and it looks like we're going to be doing it for a 24-hour span. So that's 2 cycles. The time is always runs on our x-axis, but we're going to call it t for time. And then the depth of water, this is how like deep the water will be, D for depth. Okay, so let's start. So we need to get to 20, and we need to get to as low as 8. So our maximum is at 20, our minimum is at 8. Don't worry about this 3 a.m. That's just where our start time is going to be. So we're going to start at high tide. That's all that's saying here. And it's also asking us to start at high tide right here. So let's check and see. Maybe let's go up by 2s. 2, 4, 6, 8. There's 10, 2, 4, 6, 8, 10. That gives us 20. Okay, that looks good. So we're going to start off at high tide right here. High tide. And then we got to get to low tide. Okay, and then low tide is at 8, so somewhere around here. So our graph is going to be between 20 and 8. It's going to go in here, something like this. All right, let's go look at time, and we know it's a 12-hour cycle, so maybe let's go up by 2s again. If we go up by 2s, it's going to be a little cramped. Maybe by 1s, but write down 2 every 2 spaces. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, perfect. That works out. We only have to get to 24. All right. So we know one cycle. How long is one cycle going to be? It says it right here. One cycle is going to be 12 hours. So think of like the tide is in. It's at like all the way in. That means it's high tide. So it's in the harbor at 20. And then some time goes by, and then again at 12 hours, it's back at high tide. Okay, so if this is cyclic, where do you think low tide's going to be? At what time? Low tide's right in the middle. So at 6 hours, we're going to get at 8. There we go. Okay. So now we also have to figure out our vertical displacement. And our vertical displacement would mean like the graph used to look like it was down here, but then shifted upwards. You find your vertical displacement by taking your max plus your min, dividing them by 2. So max of 20 plus 8 divided by 2, which gives us 28 divided by 2 is 14. So that's our axis, our line, our right here is going to be at 14. This is where y is equal to 14. Guess I didn't have to go that far, but that's fine. All right, so then this graph should be going kind of like down like this and up like this, and then we should have another one going on. But let's just finish this one cycle. So between high tide and low tide, we should be hitting the middle. So right in the middle between 0 and 6 is 3. So right at 3, we should be hitting, like it was all the water's all the way in the harbor, halfway in, all the way out. Then halfway in, and then all halfway back in, and then all the way back into the harbor. There we go. All right, let's draw one more. So we know after 12 hours, again, after 24 hours, we'll be back at high tide. Right in between them, so at 18 hours, we're right at 8, low tide. Between 18 and 12, right in the middle, we get back to halfway there. And right here, we're halfway there. All right, perfect. There we go. There's 2 cycles. Let's go figure out the period. Well, the period we already know. The period is 12 hours. For one cycle is 12 hours. What's our amplitude? Our amplitude is found by doing the max minus the min divided by 2. And the max is 20 minus 8 divided by 2. That gives us 12 divided by 2 is 6. Let's figure out our k value, because we don't have k. We know what the period is, 12. Well, in order to find k, we do 360 divided by k. And if we know that p is 12, right, so we could put 12 in for p is equal to 360 divided by k. That just means these two switch, or you can think of k is equal to 360 divided by p. The same, those two just switch. And we get k is equal to 360 divided by 12, which means k is equal to 30. Morning. All right, so we have everything we need, and then we'll figure out domain and range right after we do the equation. So our equation here is, well, normally we start with a y, but instead of y, we're going to name it like f at x. F at x, we used to talk about. F at x, well, f would be like our d, and x would be like our t. So d at t is equal to, and now what does this one look like? Does this look like sine or cos? If you guess cos, that's great. Yeah, it looks like cos. So instead of writing sine, we're going to write cos. But we need something in front first. We need that a value. That a value is our amplitude. It's 6. So we've got 6 first. And we're going to say cos. Sometimes it will look like sine. If you want to use sine, you can totally, but you will have a phase shift here. If you use cos, then there's no phase shift. Cos, then we need a k value is next. And we found k. K is 30, so let's put 30 right here. And since we're starting at 20, there's no phase shift, it's just going to be t. So we're not going to have to move it left or right. And then we did move everything up, our vertical displacement, d, which we found to be 14. Right? So if you really want to see sine, this is what sine is going to look like. D at t is equal to, remember sine starts at the origin, then goes up, then down and up. So sine is not going to start here, but sine starts right here. This is where sine is. We just did the equation for cos. So that's perfect. There's no phase shift. We start at 0 and it keeps on going like that. If you wanted to look at sine, sine is the exact same, 6 sine 30, but we will have a phase shift. Where is it starting? It's starting at 9 to the right. So that means we're going to have t minus 9. These are the exact same equations. They just look a little different because it just depends on where you want to start. All right, and then let's look at the domain and range. So the domain here, again, is asking for 24 hours only. So domain here, we're looking at the letter t, not x, is an element of the reals such that, and we're going from 0 to 24. 0 is less than or equal to t, which is less than or equal to 24. And then for our range here, we're talking about low and high tide. That's all to do with depth. Depth is an element of the reals such that we're going from 8, which is less than or equal to t, which is less than or equal to 20 is high tide. Right, that's the domain and range. Right, so here pointing out you have to have your labels. You have to label your axes. What you should have your middle line, and then from there you're graphing your points. So we have high tide happening, low tide happening, and then really what's the number between 6 and 0 is 3, and then that's on our middle line. So we can see kind of how that's happening. Okay, the next video will show the next question.